Okay, so maybe we start with uh, with a recap from power series. Okay, so from power series, okay, let me just give you the questions and then let's solve it. Or maybe start with the Taylor series. Okay, fine. So find the Taylor series and then find the radius of convergence. Maybe the next questions is find some of the series. We start with these first two questions. So first, I think my suggestions for the study for your study, especially for the power series representation and Taylor Maclaurin, I think you need to be more uh, familiar with some of the essential functions that you can represent in a power series, like e to the x, 1 over 1 minus x, of course, the ln 1 plus x, tangent inverse x, sine x, cosine x. So when you have at least those essentials, I think for more, for example, to change the sum into a function or from the function into a sum or series, it's much more easier to convey. If not, then the only way you can do it is you can try to take down the Maclaurin series from the scratch. Like for example, if you maybe forget maybe sine x or maybe cosine x, whether it has a factorial or not, then you can try to build the series from the scratch. So you can write down each function, take derivative maybe 3 times, maybe 4 times, and then input 0, and you will get the constant. And you put the expansions from the from the usual Maclaurin, or maybe Taylor or Maclaurin. I think if it is a Maclaurin, then you can start build your own structure. This is 1 plus factorial, 1 factorial plus and then you will see a pattern, and then you can rewrite the pattern in terms of the sum. Okay. Okay. So that's the only way you can do. So maybe the ideal is you need to know all, but sometimes we might forget the structure. So to try on, then you can build from the scratch, and maybe from here you can get the pattern and you can write down the sum. And of course, after we learn the power series representation and Maclaurin, especially the Maclaurin, from the Maclaurin itself, it already covers the power series and representation, right? Because when we have this is actually happening to most of the functions that we already learned before. So if you learn this, I think you can cover most of the second half topics. So I think this is essential to get idea from the scratch. So you can build the Maclaurin series from each functions, at least the e to the x, sine x, cosine x, tangent inverse x, and ln 1 over 1 minus x from the scratch. Okay, I think we can start for number 1. Or anyone get? What's the radius convergence? Anyone get? 1. I think it's more than 1. I think there is a constant that you need to. X minus 4 is correct, but I think there is a constant when you try the ratio test. Okay, now if you remember, let me write some review. Okay, remember that we have the power series. Let me write with blue. We have the power series that is, or probably let me just write in terms of sum directly. So sum, this is Cn and x minus 4 with power of n, right? This is the general form of power series. And in terms of Taylor, we can rewrite the Cn as f n 4 divided by n factorial. Okay. So basically, the Taylor can be written as and then x minus 4 with power of n. Now we need to rearrange and look on fn4 we have. So we need to exchange these variables. Okay, change with the given information. So we exchange, we substitute. This will given negative 1 with power of n and factorial. And then divide by, let me write 3 n plus 1 and then n factorial. And then x minus 4 with power of n. I think we can cancel this. And then we have this series. And we can write that this is the Taylor series. Taylor series for f at centered 4, or maybe centered at 4. Okay, so that's the first question, and then we need to find the radius of convergence, which we can build on from this equations. Okay, we can build from this equations. We take on the ratio test. And then we simplify the form and take the limit. Okay. So apply ratio test. So we can write the limit, or maybe you want to compare an plus 1 and an. Okay. And then later you can take the limit. But let me just write the limit at the beginning. So this will be n x minus 4, n plus 1, and then 3, n plus 1, and n plus 1 plus 1, so plus 2. And this is multiply with 3n, n plus 1, and then negative 1, and x minus 4 with power of n. Now let's cancel this, cancel this one, so this is x minus 4, cancel this, so this is 3. Okay, so we have 3 left. Okay, so this is the constant that I thought. We have 3 left. Okay, so the limit as n approaching infinity, we will have 1 over 3, and then this is x, or maybe let me write the limit later. Let me write this x minus 4, because we are just focusing limit on n. So n will be n plus 1, n plus 2, which is 1. So we can take it as 1 over 3 x minus 4. Now, since this is 1 over 3, having a constant 1 over 3x, so of course the radius will be 3 times of this constant. Right? So the radius, or we can write on solve x minus 4 is less 3. So r is 3. Okay, so since the Taylor or Maclaurin quite handy, and I think it will be very useful in some of your course in the future courses, when you learn some process, any process that concludes any factor that's related to series. I think they will be based on the Taylor or Maclaurin. Also, if you are maybe going forward to learn more about some statistics, I think also sometimes you need to have Taylor polynomial to solve some problems, especially to approximate something, finding errors. Yeah. And it doesn't mean that you need to like understand fully. At least you understand the concept. Okay. Because I think most of the time, because now we already have more like softwares that already built in, and you can just using the software. But at least you know how the software thinks, how the software works, how they approach something. Like in your calculator, they calculate something and they need to approximate. Probably they will use the Taylor polynomials inside, the computation inside. Okay, now the next question. Anyone get the idea how to solve it? And I think in the future I will put more additional videos since I think we kind of delay a week or 2 weeks. So at least for factors and factor functions, I will add some additional videos. And if you already have schedule for your midterm for either course, let me know if you already have. I think maybe physics, some statics. When? 12? 12. Same also. Any schedule you have? Fixed schedule? Not yet or not yet? I think some professor already give fixed schedule. Do you remember? Maybe other course. Is it? 12. Oh, okay, 12. Yeah, same also 12. So this I know when I can arrange our meter. So I will give some space and I think we will have to. I don't think it's wise if I take on 14, so I think it's the next week after that. Maybe around 19, maybe around 19. I think 19 is Tuesday, so maybe Tuesday for midterm. So you'll have at least time to study. Okay, for the second question, for this one, I think the most obvious giveaway is this 2n plus 1 factorial. If you looking at or observe this 2n plus 1 factorial, I think you can figure out what kind of sum will be this series. Or maybe you can take some time to see the form and maybe you can manipulate the form and then you can check with the other Maclaurin series that has this 2n plus 1. We have 2n plus 1 with a factorial and 2n plus 1 with factorial. I think for the factorials one, this will be for sine. So remember, sine and cosine, they will have a factorial in the series. So for sine will be an odd number, the cosine will be an even number. So this is probably sine, but let me just tweak the series. Let's exchange some forms. So probably we can take, let me write blue. We can take this as, let me write, since this is 2n plus 1 and 4 also with 2n plus 1, let's combine this together. And let's look on what might come from this combination. Okay, and then remember that if we have sine x and we want to write the series, we can write this in terms of this, right? And then we can definitely write down the final result as this should be sine pi over 4, which is 1 over square root of 2, or half square root of 2. So for this part, okay, either finding directly the sum, and you can exchange with your essential function, or maybe it's asking to find the first three terms, non-zero three terms, when you modify the functions, and you find also representation functions. What else? Maybe defining the series also, the interval, radius convergence. Also, you can also, if you remember the C that we have here, okay, the coefficient here, okay, maybe we can also make questions around that coefficient. For example, functions is x sine x squared. Find f at 203. Now in this question, the first step is looking at the functions and maybe think on how this looks like in the terms of the series. You need to modify the series from the sine x, modify, and then find the coefficient for the 203 derivatives. Remember it, let me write so that you won't forget the idea. Let me just write 0 and then divide by n factorial. This is for Maclaurin, the coefficient. Okay, so probably we can start with the function itself. Okay, so let me write here the functions. Okay, since I've written the sine x, so we can apply this sine x for modification of the functions. We take reference from the essential function sine. So we are going to write down that x will multiply with this sum and let me write x as x squared. Okay, let's solve and multiply with x. So this will become x 4n plus 2 plus 1, so plus 3. Okay. So this is our functions as a series. Now why we need these expressions? Because these expressions we need to find at least what n that can make this 203, right? We need to find the 203 derivative. So we need to make sure that the n, okay. So the x 203 is obtained when n is 50, right? Or we can write for n plus 3 is 203, so n is 50. Now, when n is 50, what's happened with the series? If you look on -1, it should be a positive because it's an even number. So we can write down that -1, 50, x 203, and then this is getting 5 multiplied by 2 plus 1 is 101 factorial. This is the expressions that we got. Okay, if we plug, so at n equal 5, 50, okay, to 50, this is what we get. So the coefficient, let me write here, the coefficient or Cn is equal with 1 over 101 factorial. Now this is equal with the f 203, the derivative, divide with 203 factorial. So by the end, that f 203 is equal 203 factorial divided by 101 factorial, and this will be our answer. Okay, maybe I will give you more example on approximations. Okay. Approximations in Taylor. Okay, let me go to the next page. Okay, how many terms of Maclaurin series for ln1 plus x you need to use to estimate ln 1.4 within 0.001. Which means that what we are looking for in this question is we find n. Of course, since it's related to some computations, we need to use a calculator. So for your midterm, please prepare a calculator. And then there are at least two ways for our calculus part. First, using Taylor's inequality to remember that we have to state that the m. Okay. Or second, we are using the alternate series estimation if it is alternate series. And I think if it's alternate series, it's much more easier using the alternate series estimation. So we are going to have some trial and error actually. We need to have some trial and error until we find the error is 0.001 or less than this error. We need to find less than this, and that will be our n. But don't go too far. Okay? Don't go too much. We need to find maybe nearby the 0.001. And probably at the end of the day, you can check the confirmations, whether the answer and your approximation is close or maybe within the error. You can check ln 1.4, what's the number, and then you can check with the sum, whether it has this gap or not. But first, let's understand the question. How many terms of Maclaurin series for ln 1 plus x? It's already giving you information that, okay, we need to at least looking on Maclaurin series. So ln 1 plus x, we'll write the ln. Ln 1 plus x is equal we know that this is our representation for the series. So when we have ln 1 plus 0.4, as it's mentioned that it is our goal, 1.4, we are going to have the series which started from n equal 1, and then we can exchange x with 0.4. Okay. Now we need to know which n we need to have until we get the error is 0.001. First method, or if you understand the question, it takes n equal 1, equal 2, maybe equal 3, 4. You take some time to plus those numbers, and then compare with the actual numbers, whether it's going to have the error within this accuracy or not. Or if you observe the series, it has negative. Of course, this is alternating. And if we look on how the series build, I think we can take this and we can check some of the error within the, so some Rx that is stated from, or maybe we can take this as n. The alternating series is having just n plus 1 and then n plus 1. So again, we can check one by one. Check R1. So check several n. Check several n. So probably start from the first one when n equal 1, or this will be 2, or maybe let's say this is start from 0.4, and then let's start with 2. 2. What's the results? And if you check all the n, you will end up with when n is 6, and its result in, if you check the number, this is 0.0007. You can compare with 5. Actually, you can compare with 5 whether it's and I think it's between 5 or 6, but well, let me just take 6, which means if this is 6, then n plus 1 is 6, so n is actually 5. Okay, so we need 5 first non-zero terms to get into 0.001, okay. At least less than 0.001. If you want, you can also conclude this with some calculation of the sum itself. You plus, maybe having some results, and you can check the difference between the actual number of L and 1.4. You can go for that way. maybe to finish this session, let me just give you one more questions on the series. Some series, they are not particularly can be determined from the method that we have learned. We have learned to describe this element. Actually, we remember last few weeks. So you can start, try this one. Maybe it's having break, but if you already have break, maybe you can start this one. And then the idea behind this series is we need to do something with this inside of ln, and maybe there's something about ln that is important if you try to modify the form. I think we can have a short break. Okay, so just a reminder that if you read your textbook, in chapter 11, there are some essential functions for Maclaurin. In your textbook, it's mentioned the binomial series. That part, we skip. Okay, we skip. We are not included the binomial series into our midterm and also our course this semester. I think it's enough for other essential functions for now. Okay, let's go back to the last question here. The idea behind the series is if you look on how the ln forms in the series, the first thing you can do, okay, try this n equal to 3, 4, maybe 5, and try to look on what kind of numbers it makes. So maybe try n equal to ln 1/4, okay, and it becomes 3/4. And if you take 3, it becomes 9. So it will be 1 minus 1/9, which is 8/9. So 3/4, 8/9, plus 8/9, and plus other number as well. If you think that you don't really get anything with that, then maybe we need to rewrite this into another form. Okay. So first thing we can do is let's go check our ln. Okay. So let's try to rewrite this form. Maybe we take the combinations and write it down like that. Okay. And then perhaps, because this is quadratic, okay, it is squared. So perhaps we can factor n squared minus 1. So let's factor it, become n plus 1, n minus 1. Okay, let us try that. Okay. Now another thing also, because we are dealing with ln, remember when you have ln, a over b, we can rewrite the form as ln a minus ln b. Okay, so let's also try to write in those terms. So we can write as ln n plus 1, and let me directly write plus ln n minus 1, and then minus ln n squared, and since this is n squared, we can write this ln n squared as 2 ln n. Okay, now we have this. It's a good way of writing, but this is not our goal. It's still complicated, still complex. If we try to make n equal to, maybe you've seen some numbers, but I don't think it will help you to navigate on the series. Now what we are going to do, we are going to take this, okay, and make a new combination. Make a new combination. So the idea is, we have a negative here, negative here. Somehow, but we are going to have, we have two L and N. We are going to separate this L and N to each of this. Okay. So let's try doing that. So first, maybe let me write ln n minus 1, and then minus ln n, okay? And then minus ln n, and then plus ln n plus 1. Okay, the first part, this become ln. And this become minus, let me write in terms of minus. Okay, so this become minus ln n plus 1. Okay. Now I think it means something. It means something. Okay. So you have several trials actually. If you do normally, what you need to do is you need to figure out how you can rewrite the form. It's too complex, maybe you need to rewrite in another form. So let's check this out. If we have 2, this is 1 over 2, 2, and then 2 over 3. Right? Let's say we have 3. This has become 2, 3, 3, 4. That's 4. It's become 3, 4. There are some patterns that has the same numbers in each end. Okay? So let's try to take on the subject of the series itself. So we can write this, and let me write sum of n. Okay. So let's check n equal 2. It starts from ln 1 over 2 minus, or let me write with the bracket, minus ln 2 over 3 plus n equal 3 and 2, 3 minus ln 3 and 4. If we try 4, this will be ln 3 over 4 minus ln 4 over 5. And I think it's enough to convince us that the middle part here, if we add more and more until infinite number, the middle part will be cancelled. And that is what we call the telescoping method. So that's one way to solve the series using the telescoping method. This is called a telescoping method. I'm not sure why it's known as telescope. Maybe because we are trying to look on the far left and far right of the object, and the middle part is cancelled, all cancelled. So we can have plus plus the very end. Let me just choose some n. Or maybe if this is quite ambiguous, if we have this limit, then maybe we can take the integer maybe k. So let's say this is the partial of k. Okay. And we can take this until k. This will be k minus 1 over k minus, and k plus 1. Okay. Now to become infinity, we can just take the limit. Okay, we can take the limit. So this will be equal. Let me just write the first equation. This is limit as n, or as k for now, of our sk. So limit. So since we have cancelled all the middle part here, so we are just looking at the very left and the far right and far left. So ln half minus ln k plus 1. Now we can write the limit as minus ln and then limit. Okay. Now this limit is 1, right? So we can write down that ln half minus ln 1. Or this is just a ln half. Or this is a negative ln 2. That's the answer. So this is another way to see how we can solve the series. Okay, so it's called the telescoping method. I think I have given you some examples, but that's pretty much simple example of telescoping. But this is one more difficult question related to the telescoping method. Okay. Okay. Any questions from here or maybe from the previous one? Do you have any confusion? Okay, I think we have a lot of content in chapter 11, right? So we delayed a bit from the schedule. And if we are not having enough time in class for, especially for maybe chapter 13, because chapter 13 is actually very short, I will add some additionals to help you for this discussion, and in the class you can focus more on the discussion part. So I will give you some introductions, maybe what you need to have, and then I will just review in the class and give you a practice. I think in one or two, in the 2 meetings, I think in the 2 meetings, chapter 13 can be done. Because chapter 14 and 15, again, it's like chapter 11, it's a lot of content. Okay, now I would like to start chapter 12. Okay, chapter 12, the factors. So I hope you don't mind. And for practice, I'm giving you some not a homework, but like a testing in the quizzes like you did in the previous semester. That is just to help you exercise chapter 11. So probably tomorrow or maybe Thursday, I will upload the link on the Moodle. Please check the link, and I will give some durations for the test, at least until next week. So maybe 6 to 7 days. You can choose which day you are going to use the platform. Okay. And I hope you can test yourself, okay, and then see whether you are able to complete the test or not. Okay, let's continue. So as I mentioned, we are going to have a new chapter, so chapter 12. So first of all, we start with the introduction of three-dimensional coordinate system. And I hope you're already familiar with this. Okay. So 3D coordinate system. And also you can also imagine this coordinate system as in your right hand. Okay. So this is going to have Z, X, and Y. It's similar to what you have done in, I think in physics, you also using the right hand. Also for having the electromagnetic, if you remember, right? And then the other part that's important is to state the point in our system. Okay. So if you remember, our 2 dimensions have 4 quadrants, right? In 3 dimensions, we have 1, 2, 3, 4, and 8. So 4 here and 4, like a sphere. Okay? If you remember, if you imagine into a sphere, so we can cut the sphere, and if you look on how it looks like, it will be having 4 area inside, 4 region, or each one having 4, 4, so it's 8. We call also octant. So before we have the quadrant, first, second, and after 4, we have now 8 octant. But mostly we are dealing with the first one here. This is the focus one, usually. Okay, I hope you're familiar with this. The second part of the three dimensions is to note that if we are having a surface in 3 dimensions, let me write 3 dimensions like this, then if we have z equal 3 or maybe y equal 5, how can we draw this? Okay. So if usually we have line. We have line in 2 dimensions, and we can just draw the line based on what numbers to do. But now, since we have the 3 dimensions, what we are going to have when we deal with z equal 3, this will have a surface or solid surface. Okay. So we are, let me draw. Okay. Or let me check whether I have the graph or not. Oh, I think I have the graph. Let me just take this image. Okay, now we have a plane. Okay. So this plane is not restricted. It's flowing like to infinite here, but it will be crossing the z equal 3. So instead of line, we'll have a surface. We also have y equal 5 here, same surface. So whenever you have these terms in 3 dimensions, you will have a surface. Okay. So that's the introduction. Now we might have another way to look at is we have x squared plus y squared equal 1. And z equal 3 in one graph. So maybe probably this which points satisfy these two. Okay, so first we can think the first one as a circle in 2 dimensions. The second one is the surface. So it will be so let's say this is z equal 3 maybe here. And since we need to have x squared plus y squared equal 1, or the circle, so this will be the circle. So this means that we have the circle and the surface, we combine together. We have the circle as a surface that's crossing the 3. Okay. So this is just a review that you need to remember. So this is the point, and then which surface, or maybe not which surface. what does the x squared plus y squared equal 1 represent as a surface. So without any restriction on z. So this is simply, we have a circle without any boundary. So it will be going to have like a cylinder, okay? So without any boundary for z. Okay? So we will have okay, so this is having a cylinder. Okay. Okay, now if I'm giving you for maybe y equal x, how we can draw y equal x in terms of the three-dimensional space coordinate. Now, why I need to give you all this information? First, we need to build our familiarity or our visuals, where we deal with some functions or maybe equation that we already know how to draw in 2 dimensions and how to transform into 3 dimensions. So y equal x, this is just a line, right? It's a line from our 2-dimension perspective. So if we draw, let me make a little, okay, like that. So if this is the x and y, now probably this will be our y equal x, right? And probably this will be our surface. Okay. So I hope you get more familiar with 3 dimensions. Okay. So first is about this the coordinate system. The second about the surface that you can make on from how to transform. And then if you have a circle, for example, equations that satisfy with certain z, and you can also maybe take some inequality for z, maybe from z equal negative 3 to 3, okay, or maybe from anywhere in z. Okay. Now another part that still related to our introductions is the distance. Okay. So if you look on this shape here, you see some point, and if we deal with the P1 and P2, P2 is this is x2. Why was it disappear? Okay, now distance of P1 and P2 you can write as, it's actually similar with the 2 dimensions, but we need to add the z1 here. this is x2, x1. Okay, similarly, if we approach using a sphere, let's say we have a point here. So r, or the radius here, is equal with same formula what we built before. So this is equation of sphere. With center C, H, K, L, and radius R. Or when center at origin, this become x squared plus y squared plus c squared equal r squared. That's the introductions. Okay. So from 3D coordinate system, how to deal with the surface, the distance, and we can also take it as a sphere. And now we are going inside more deeply on the vectors. Okay, I think I can move on to our vectors. So 12.2. How we can describe vectors? Usually we can describe vectors as an arrow. Let's say from A to B, and maybe we can describe this as vector U. Some professor, maybe some textbook, they write just U like that and then make a bold. But since your writing cannot make bold out of your pen, and maybe you cannot differentiate between the other writing, so we can also add arrow above the letters. Okay, this is also okay. Or sometimes we are letting this U as, if you write in terms of AB, it's AB is having an arrow. So it's stated that it's going from A to B. Okay, the vectors, how the vectors directions. Okay. So idea of vectors, okay, that everything has that have the magnitude and direction. I think everybody knows this. Okay. And if we add the vectors, maybe if we have So if this is u v, this part will be u plus v. So vectors, okay. If you still maybe not familiar with vectors, the idea behind the vectors is like a playing a game. So from the start to finish, and then the result will be the addition. And if you take the minus, which means the opposite sign, then the direction, maybe if we take u minus v, then we can take v as this direction, and so this will be the minus v. So we can also write down and make sure it's going to have direction here. Okay. So vectors is like playing a game, finding this from start to finish, and you can actually make out from any perspective. And when you have, for example, this one, let's say we have, this is v, this is, let's say u. This is actually similar to what we have done here. So we can move the vectors here, and then this will go the same result. Okay, just a quick review. We call this a parallelogram law, or yeah, but I don't think the name is important as long as you know how to deal with the vectors. Okay. I think vectors is something that we experience in our daily life, actually. And the gravity for obvious example, or maybe in some places when you're traveling maybe go hiking to some mountain, not just hiking to some sort of vacation spot, but really take on hiking to like a big mountain. You feel maybe when you are on the top, sometimes feel more heavy usually, and in some place that has more magnetic anomaly, you'll feel maybe sometimes dizzy. That's because the magnetic resonance with your body also, and then that's also vectors. So your body radiates electromagnetic, right? Your body has electric, and behind this electric, of course, will relate to some electromagnetic. So you have some radiations, at least in your whole body. Sometimes when you deal with places that having magnetics around it, sometimes you feel not really fine, like being dizzy, and you will feel that when you are going to take some mountain, because some mountain they will have some magnetic inside for some resources, especially they have like for example mining, of course they will have a magnetic there. Okay, so this is called the parallelogram law. And then if C is scalar, V is vector, and ZV is multiplications, okay? This is a vector whose length is magnitude C times length of V. And it has same direction with V also. if C is 0 or phi is 0, then C phi is equal to 0. Which means that if we have this is U, then maybe the half of U is maybe like this. Or maybe if you take twice, it becomes twice. Okay, one more part, okay, I think, and then we can take some feedback. So if we have three dimension, so given, let's say point A is x1, y1, z1, and B is x2, y2, z2. Then vector A, or let me write, if vector A is equal to AB, vector AB, then A, we can write A as x2, minus x1, y2 minus y1, and z2 minus z1. Okay, another one is magnitude or length. For 2 dimensions, we can have, so for vector A, A1, A2, this is what we have. And for A in 3 dimensions, we just add more to the equations. Okay, I think I'll just stop here. And after this section, we have some short feedback time as usual. Okay, you check your chapter 11. Maybe if you feel not familiar with some English terms in the factors, maybe you can review or what you have learned before, and then maybe compare with the terms. Compare with the terms. Okay, I think this is just introductions, and I don't think it's really complicated, right? Okay, I think we can check our okay, let's check our understanding on chapter 11. Okay, and this is also to check whether you are able to calculate or maybe evaluate the questions. I think also need to check your limit of time. Okay, we will start in a minute. Okay, I think we can start. Okay, get ready. Okay, get ready all. Okay. I hope the time is okay. The first one is, I think you need to look on your phone more clear. It's too small here. True or false? Quick statement. I think it's too fast. I think maybe 50 or 1 minute. But I hope you can get the idea of the sum, the series. It has factorial, so maybe it gives you an idea on how it should be. Okay, it's true. It's e to the x, and you can change the x into a negative 1. Okay, next question. But let me see. Okay, Dr. Centipede. Who is Dr. Centipede? Okay. Okay, next question. Number 2. And giving you options. I hope if I give options, it gives you an idea how to get those options. Because sometimes when you deal with the multiple choice, I think I did this method maybe in high school. You can check each option whether it's true or not. That's one way, but I think you can also do it from the series. Oh, okay. 1/4. I think it's too short, right? The time? Do you think? Too short or so? Okay. Which one? 7? 7? 7, okay. Okay, question 3. Okay, 1:40, 1 minute 40 seconds. Oh, enough. You can check your notes. If you want, you can check your notes to make it faster. It's pretty obvious because it has factorial, so it should be related to e to the x, e to the x. Right? But how you can transform e to the x to that series? That's the question. You need to be careful, okay? To be careful. Check the end carefully. Oh yeah, everyone put it? Yeah. A. Okay. So careful with n. Okay. You should be having -1. You check n0 and 1. Okay. So you should have some n -1 at the answer. Okay. Okay, still. Okay, still. Okay, can we have another one? Okay, get ready all. I'll have the time, okay, 1 minute 45. X over sine x. We can check sine x for Maclaurin, what will be. Sine x will have this some odd number, right? For the Maclaurin. So what will be happening if you define x with sine x and then rewrite into the first 3 non-zero terms? Careful on the positive and negative. Careful. Okay, it's D, should be all positive because in subtraction you have minus, so minus will become a positive. So yeah. Okay, let's see. Yeah, I think still. Yeah, still number 1. Okay, so thank you for today's, and see you Thursday. We still continue on chapter 12. But I think if I have time, maybe we can try 1 or 2 exercises on chapter 11. So that will be the end of our lecture.